Okay, so here we are. It is April 22nd, 2025. A certain math teacher is turning 53 years old today, so he's feeling pretty old. I know. We have 4 questions here where I'm giving you one of these 4 things: words, inequality, line, or set. Whatever one I give you, you give me the other 3, and all will be good. So the first one says all numbers less than 5. So we know that all numbers is going to be represented by the variable x. Less than, I'm going to put, since I said x or all numbers, less than has to not eat what I said because it's less than and 5. So that is the inequality that represents the sentence. So that's what we call the inequality. The number line that represents that, we usually put the number in the middle and then just put the nearest whole numbers. Usually that's the way you do it. All numbers less than 5 means it cannot include 5, therefore it's an open boundary. And my arrow goes that way for all numbers less than 5. And finally, a set of numbers that would include, that would be one of them. Then this one over here, which I can't see, which would be 3, 2, etc. to infinity. Those would all be values. Now what you should do is just double check these are right. Take one of them, substitute it in. Is 3 less than 5? Yes, we're good. Okay. Second one, you see the x, you write all numbers. That's what the x means. Since I said all numbers and it's eating what I said, I say all numbers greater than, or because this line is here, I say or equal to. It can be either. All numbers greater than or equal to, thank you, Riley. -1. All numbers greater than or equal to -1. That is my words. My inequality is that. My number line, all numbers greater than or equal to -1. I'll put that there. I'll put -2 here. I'll put 0 here. Because it can be great or equal to, I'm going to use a closed boundary. And any number that is greater than or equal to -1 means my number line goes this way. And a set of values, -1, 0, 1 are all relevant values it can be. Mike, what does it say? Good. Greater than or equal to. And Mike, just refresh my memory. How did you know it was or equal to? Because it was a closed boundary, that's right. All numbers greater than or equal to 1. All numbers greater than or equal to 1. That is your inequality. And finally, your set of numbers, any number that's greater than or equal to 1. So 1 is equal to 1. Any number greater than that, we'll go 2, 3. That is a potential set of 3 different values that x can be. And then our last one's a tricky one, because there are actually infinite possibilities for a solution. There are a bazillion solutions for this, and I'll just show you the one that you probably should have written. So if I say all numbers greater than or equal to 4, that would be the simplest inequality that you can use. But you could also say all values greater than 3. That would also be a true solution for that particular one. I could just say all values greater than 2. I could also x plus 1 is greater than 3, greater than or equal to 3. I could say that as well. I'm going to keep the easiest one. That's the easiest solution. And therefore, 4 goes in the middle, 5 goes over here, 3 goes over here. All values greater than or equal to, closed boundary, greater than or equal to. I should have. All numbers greater than or equal to 4. I didn't include an ellipsis in this one.